6-5, day 2. No pre-lesson. Just going to take what we learned in day 1, apply it to some application problems. They start out with a doozy. So, if you go to page 329 in your textbook, look at example 4. You got this problem here, equation. You can see the log in there. And this has to do with the pH levels of things. Now, commonly, we think of pools needing to have the proper pH, you get a pH testing kit and all that. This is the formula that actually calculates pH. Now, what is pH? It's the concentration of hydrogen ions. This symbol right here, which is kind of crazy, got a bracket and an H for hydrogen with a plus, a little chemistry symbol there, is the concentration in moles per liter. So now let's look at this question. It says, what is the concentration of hydrogen? Now look, this word is concentration, this word is concentration. So it's like, ooh, which one am I trying to find? Well, it says of hydrogen ions in the acid rainfall. So if you look at the picture on page 329, you've got different things like an orange and acid rainfall with different pH levels. So they tell you the pH of the acid rainfall is 4.5. That's kind of telling you where to put it. So we know we're going to put 4.5 in for here. Now watch this. 4.5 equals the log of 1 over this crazy symbol. Now, if you wanted to just put an X in there and remember what it is, I'm sure that's fine. Looks like, how do I solve this? Remember our rules. Division, this is the mole, boom, log of the numerator minus the log of the denominator. I'll stick with the symbol for a while, equals 4.5. Now in a previous moment I said this is kind of like a law. When you see a 1 right in that position, you know, because this is what it really means. What does that equal? 0, because 10 to the 0 power is 1. So that just goes bye-bye. So I can squeeze this together and I get 4.5 equals. Now, I still need to solve for this. So I'm going to spin it around. You don't have to. But there's an invisible 10 right there. And I just prefer it written this way. 4.5. Now I look at it, I go, aha. This is just 10 to the 4.5 power. I forgot something. So I want to get rid of that negative, okay? So I'm going to multiply that by -1 first. Forgot that. So this would cancel. And then this -1 would hit this, making that negative. So really, I'd have, let me rewrite it so I don't confuse you. And now let's restart it. So 10 base exponent -4.5 equals this crazy looking thing. And now it's like, okay, what is this? Well, if you type it in your calculator, which I did, 10 to the -4.5 power, there's 4 zeros and then a 316. 1, 2, 3, 4, 316 equals the concentration level of your acid rainfall. There's your answer. Remember, to type that in, 10, and then caret, and then you type in -4.5. Don't use the subtraction sign, use the negative button on your calculator, and that will calculate that for you. Which is that. Done. Got one more example like that. So what if they ask you the same question, but now it's about the orange juice? If you look at the picture tells you the pH is 3, so you know what to put in here. You put a 3 equals log 1 over that crazy looking thing. Now we're off to the races. So what does that turn into? It turns into 3 equals, now we're going to take the mole for that log, And we know that this equals 0, so it really turns into this. Now, I'm going to do two things. I'm going to multiply both sides by -1, so I want to get rid of that. So, and I'm going to spin it around. So log of that weird looking thing equals -3. Remember, there's an invisible 10 there if there isn't something in the base position. So now 10 to the -3 power equals what we're looking for. And then that is just the same. You can type it in your calculator, but it's the same thing as 1 over 10 cubed, which is 1 over 1,000, which has a decimal, and they do write this stuff in decimal notation. There you go. Whoops, that's a plus. This would be fine, but they do use decimals in terms of pH, so there you go. In this section, if you notice example 5, I forgot what page it's on, but example 5, they introduce you to this thing called a change of base formula. Now, sometimes less is more. So instead of introducing you to a brand new formula, we're just going to use our noggin and stuff we've learned before. We're going to tackle these problems based on what we've learned how to do. So this problem is just saying, okay, 2 to some power, we don't know, so you've done these before, equals 3. It's like, okay, we're going to start with 2 to the x equals 3. And there's no way you're going to be able to figure that out. So this is one of those where like common basis, happy places, not happening. So I got to slap a log on this side, slap a log on that side. That allows me to bring that x into the front. So it's x times the log of 2 equals the log of 3. Got to use our calculators for these. Uh-oh, no glasses. Log of 2 is 0.301, so that's 0.301x. And the log of 3 is 0.477. You can see what to do here. 0.301 gone. 0.301 and x is 0.301, 1.58. There you go. So let's tackle this other one without using the change of base formula. The change of base formula basically just has you put stuff in places, but you don't really understand what's going on with a log. That's why I want you to do this. I want you to practice what a log is and why it's beneficial. So this, remember, there's always 3 pieces. So start here, go there, go there. 5 to the x power equals, I'm going to leave a space, 3. Why do I leave a space? I can see common bases, happy places. That's not happening. Slap a log there, slap a log there, bring it down the front. X times log of 5 equals the log of 3. Now we just did log of 3. I'm going to cheat a little bit. 0.477. Find log of 5 by simply typing in log of 5. 0.698. So that's 0.698x equals 0.477 divided by 0.698. X is, here we go, 0.477 divided by 0.698. 0.683. Done. All right, no change of base formula. Okay, a little different looking problem. Now just to kind of build a bridge, remember we just did a problem like this. So this one has a log in it already. This one doesn't. So this one, because it's a log, we treat it like a log. We're like, hey, there's an invisible x there. And that's kind of how you get started. 2 to the x equals 3. Now I'm not going to do that problem again. But you see, this requires that you go to here, then you slap logs on. This problem, there is no log. It's just a problem. Common basis, happy places, not happening. So I'm going to slap a log on this side. I'm going to slap a log on that side. That allows me to bring the x in the front. Log of 2, I think that was 0.301, I hope I'm not wrong, equals, I'm going to figure out log of 7. Log 7.845. Now I can divide by 0.301, divide by 0.301. These cancel, so x is 0.845 divided by 0.301. Boom. Whoa, 2.807. We'll just go 2.8. So, understand, problems are going to be given to you differently, and you need to know how to respond. So if there's a log in the original, treat it like a log. If there isn't, just ready to slap some logs on both sides and get her done. I think that's it, you guys. You're ready for your homework, just like that.